I'd like to begin this presentation in the way that I do when I'm talking to a room full of producers as well. And that's by saying that I've been working in small ruminant and parasite control for a number of years, and I also appreciate how difficult it is to get everything right in sheep and goat production, because my husband and I own a small flock of sheep in southwestern Virginia that you can see in the photograph in this presentation at the end of a very dry grazing season a few years ago. I also want to point out that because I'm a sheep owner, I have a tendency to say sheep when I mean sheep and goats. So if you hear me say sheep and not sheep and goats, I mean both. Sometimes I just abbreviate it a bit. If I have something specific to say about goats, I will identify that quite clearly, so you know I'm addressing goats in particular. The major health problem at this time faced by sheep and goat producers in most of the eastern and midwestern United States is the parasites of the gastrointestinal tract, the worm parasites of the gastrointestinal tract. And that's what I'm going to talk about in this presentation. Now, there are some other parasites that you may have encountered and may be curious about. Probably the most common one of those other parasites that cause problems would be the coccidia. Coccidia are single-celled organisms that live in the GI tract. They are a common cause of diarrhea, especially in young animals, but I want to be quite clear here that what I'm talking about is worms and not coccidia. And the best management practices that I'm going to be telling you about will not work for coccidia in many ways. Some of them will, others won't. Coccidia require different drugs. They thrive under some different conditions than the worms do. So really, coccidia is a separate subject. And I've given you a link to a web page here which can provide some information specifically on coccidia. A couple of the other common parasites that we see or commonly encountered parasite problems would be, firstly, tapeworms, which are very common in sheep and goats, again, especially in the young animals. They are dramatic. And if you've ever seen big wads of tapeworm material in sheep and goat or goat manure, you've probably been horrified and think that these parasites must be causing a huge amount of disease in your animals. In fact, they don't. And we know through a number of studies that have been done that even though they're big and they take up a lot of space in the intestinal tract, they really don't seem to be associated with disease in animals, and they don't seem to have, under typical circumstances, they don't seem to have any impact on weight gain or production. Another parasite that is of great concern to people can be a serious disease problem, and that is meningeal worm or brain worm of white-tailed deer. It's not a problem in white-tailed deer, but when this parasite gets into sheep or goats or alpacas, it can migrate through the spinal cord and cause central nervous system disease. This can be devastating in some animals, but again, it's not really the focus of this presentation. And so there are other sources of information that you can go to find out more specifically about the meningeal worm. So I'd like to divide today's program up into three parts. The first part is what you really need to know about worm biology to win the war on worms. The second part specifically is going to address the resistance problem that we're facing now with dewormers. And then finally, I want to talk about what you can do in order to develop an integrated control program for your own flock or herd. So let's start off talking about what you really need to know about worm biology. It's quite clear that the most important of these worms that live in the stomach and the intestine is the barber pole worm, Haemonchus contortus. This parasite lives in the abomasum of sheep and goats. The abomasum is the portion of the forestomachs of a ruminant that's analogous to the stomach of single-stomached animals. So the abomasum is sometimes called the true stomach. This parasite exploits many environments and management practices, and it's so adaptable. It is such a miraculous creature that it's found from Florida to the Arctic Circle. And anytime you have animals, sheep and goats on pasture, you're almost always going to see at least some level of Haemonchus contortus infection. This photograph shows the abomasum of a sheep that died of Haemonchus infection. That abomasum, the stomach was opened up, and what you can see on the surface of the stomach is lots of red material. And that red material is all worm. It's clumps of worm carpeting the surface of the abomasum. Haemonchus contortus, barber pole worm, is sometimes also called wire worm, is not a very big parasite. It's only about an inch in length, but the intestinal tract of the worm is very red. The reproductive tract is white, and it wraps around the intestine. And the wrapping effect leads to the appearance of a red and white striped parasite looking very much like a candy cane or a barber pole or a piece of wire, hence the common names of the parasite. Now, the reason that the barber pole worm looks like a barber pole is that it has a red intestine, and the intestine is red because this parasite is feeding on the blood of the sheep or goat host. The way the parasite is able to feed on blood is that it has a little tooth, a hard little tooth. And in the top photograph, you can see the arrows pointing to a small triangular structure that sticks out of the anterior end, the front end of the parasite. And that little tooth actually slices the surface of the stomach and causes bleeding onto the surface of the stomach, and then the blood is sucked up by the parasite. Because of its blood-feeding habit, the principal clinical sign that occurs in animals that are heavily parasitized is blood loss anemia that shows up as pale mucous membranes. And in the photograph of the eye of the sheep here, you can see the arrow pointing to a very pale mucous membrane around the eye. It should be nice and bright pink. So these are anemic animals. The anemia is also associated with weakness. As the animal loses its red blood cells, it becomes weak. Another sign that's very typical of Haemonchus infection, severe Haemonchus infection, is bottle jaw. And you can see bottle jaw demonstrated in the goat, the arrows pointing to a mass of fluid below the lower jaw. That's edema that develops because in addition to losing red blood cells in heavily infected animals, they also lose blood protein. And when blood protein levels fall, animals develop edema or accumulation of fluid in the tissues, and that edema shows up first in the submandibular area under the lower jaw. Even in animals that don't show obvious pale mucous membranes, obvious bottle jaw, you may get decreased weight gain, decreased production in lower level infections. But one thing that Haemonchus doesn't do is it doesn't cause diarrhea. And that makes the effects of this worm even more insidious because owners will stand at the fence and look at their animals. They'll see there's no diarrhea, and they'll think, well, I can't be having a problem with intestinal parasites, or I would be seeing scours or diarrhea. In fact, animals may be close to collapse from severe Haemonchus contortus infection, and there's no clear clinical sign that you can see from a distance. What's amazing about this is that when you look at an animal like this, the whole surface of the stomach is moving with the activity of these worms. There may be thousands and thousands of them in an individual animal. Now, there are some other worms that are related to Haemonchus. They're in the same family as Haemonchus that live up and down the gastrointestinal tract as well. We say barber pole worm is the most important of these worms, but there are other worms like brown stomach worm, Trichostrongylus, Couperia, other related worms. When they're present, they don't help the situation. They assist Haemonchus in reducing the health of the animal. Usually these other worms by themselves don't cause disease, but sometimes they can. Under some specific circumstances, we may see diarrhea associated with some of these other worms. But by and large, without a doubt, the primary worm is Haemonchus contortus. So we have in ruminants a neighborhood of the GI tract. And in that GI tract neighborhood, there's a whole bunch of members of the same family. They're related to one another. You can see in the abomasum, we have Haemonchus, Ostertagia, Trichostrongylus axii. Those are all scientific names. You go to the small intestine, you find other members of the family, and there's some too in the large intestine. They all play a role in what we call parasitic gastroenteritis. But it's Haemonchus that we really, really need to control. And when we control barber pole worm, we really are effectively controlling the other worms as well. Now, all those worms in that family have the same life cycle. So that's fortunate for us because so much of what we do in parasite control is addressing, interrupting the successful life cycle of the worms. So these worms all work in basically the same way. We have adult parasites in the GI tract, in that part of the GI tract that they prefer. The adult worms pass eggs. They release eggs that are passed in the manure of the animals, and they can produce large numbers of eggs. Barber pole worm is probably the most fertile of these parasites, and female worms pass thousands of eggs every day. You can see here the statistic that 200 female barber pole worms can produce 1 million eggs in a day. And 200 of these worms in an animal is nothing. You'll often find much, much higher levels than that. So if you think about your farm and the pastures on your farm, you can just imagine them being blanketed by these parasite eggs. The eggs develop. Inside the egg, we have larvae that form, and then once the larva has formed, the egg hatches, releases that larva into the fecal mass. So the eggs are still in the fecal pellets. They stay there, and the worms eat bacteria and develop. So they go through a couple of larval stages, just feeding on bacteria, getting bigger, and eventually they turn into this third stage larva. And that third stage larva is the stage that's infective for a sheep or goat. Before the third larval stage, they can't infect anybody. They're restricted to just being little larvae living out in the environment, eating bacteria. Now, one of the critical things to when you have worm problems and how you can think about controlling worms through pasture use is knowing that the process, that period of time required to go from the egg to the third larval stage, takes a variable length of time. The cooler it is, the longer it takes, because the worms are entirely controlled really by the temperature that they encounter. So when it's cool, it takes a long time, weeks, maybe even months, to go from the egg to being a stage that can infect a sheep or a goat. But the warmer it is, the faster it occurs. And when it's really warm outside, in the middle of worm season, in the middle of summer, when temperatures get into the 80s, maybe even a bit more, and it doesn't cool down a lot at night, the minimum amount of time it takes is about 5 to 7 days. So once the third stage larva is formed and is able to infect a sheep or a goat, those larvae move out of the fecal material, the old fecal material, and get out onto the pasture, onto the forage. And then as sheep or goats are grazing, they pick up the worms and become infected. It takes about 3 weeks after infection for those larval parasites to turn into adults, for males and females to mate, and then for the females to start producing eggs. Now, what you need to understand and be absolutely clear on is that if your animals are grazing, they have worms. There is no way to eradicate them or prevent that. These worms are so successful that animals on grass are going to have some level of infection with these parasites. And what we're trying to do then is to lower the level of infection that they have to control it. By the same token, where we say grazing animals have worms, in fact, animals that are kept off grass may have other parasite problems like coccidia, but they won't have very big worm problems because the larval stages really do best on grass. They don't do well in housing. I think high ammonia levels with animals that are kept on dry lots and they're urinating and onto the fecal material, that kind of situation, those larvae don't do very well. They want to be out on grass. So if you have animals with worm problems, you bring them in off the pasture, put them in the barn, they're not going to reinfect themselves again. Now, there is some other useful information that you can use in designing integrated parasite control programs. I'm often asked questions like, how long do adult worms live? How long can the infective larvae survive on pasture? Can these larvae survive winter weather? And when is worm season? When do worm control programs need to be most active? So to answer these questions, firstly, how long do adult worms live? They usually live for about a few months. So you might have thought that when an animal becomes infected with Haemonchus, that those adult worms could go on shedding eggs for years. They don't. Adult worms really only have a span of several months in which they can reproduce. So how long can these infective larvae survive out on the pasture? Once larvae reach the point where they're able to infect a sheep or a goat, they can't eat anymore. So they're out there with a limited amount of metabolic reserves. And as they stay in the environment, waiting, hoping to be eaten by a host animal, they're going to be using up those metabolic reserves. The warmer it is, the faster those worms move around, they wiggle, and are able to move around a bit on the pasture. The warmer it is, the faster they wiggle, the faster they use up their metabolic reserves. When it's cool, they don't move very much. And when it's cool and moist, that's perfect for worm survival. And the larvae can survive for months at a time. So their survival on pasture is really dependent on environmental conditions, not just on the characteristics of the worm itself. Now, how well do they survive winter weather? Some species of these worms in the GI tract really don't mind cold winter weather and survive freezing quite well. Barber pole worm does not like freezing weather. And that is a very helpful thing for us because it means that when you have cold winters with freezing weather, many episodes of freezing and thawing, you will kill many of the barber pole worm larvae that are on the pasture. But some always survive, and other species may do better in freezing weather. However, barber pole worm and its relations have another strategy for getting through cold winter weather, and that is to spend the winter time in the animal. So what we see in many parts of the country with cold winter weather is that the larvae, when they're eaten by the host, the sheep or goat host, the larvae in the fall will go into the wall of the stomach and then just sit there. They don't continue their development. They don't become adults. They just sit as dormant larvae in the stomach. They're called hypobiotic or arrested larvae. And then come springtime, they emerge from the stomach wall. They continue their development, become adult worms, mate, and start egg production. So this is a tremendous adaptation for them, that they don't produce eggs at a time of year when the eggs wouldn't do very well on the pasture. They keep their reproductive effort for times of year when they're going to be more successful. But what it means for you as a producer is during the wintertime, your animals may have lots of worms in the stomach wall, sitting, waiting, and you don't know that. There's no way to measure the level of infection at that point. There's no way to look at a fecal or look for clinical signs, because those dormant worms don't produce disease, they don't produce eggs. So when is it worm season? And basically, worm season occurs when temperature and moisture best support the worms outside, not in the animal, but outside. And it's the environment that controls when we see most of the parasites. In Vermont, worm season then really is a very short period of time, kind of July and August usually. Outside of those months, transmission is going to slow down because it's cooler. However, for us in Virginia, worm season probably goes from June through October because we have such good conditions that favor transmission of the parasite. And if you go farther south, you may encounter places where it's worm season all year long, and their headaches, producer headaches down there are just overwhelming sometimes. So really, it's the weather. Weather is what tells you when your worm season is. And I like this quote from Robert Heinlein that climate is what you expect, weather is what you get. So you're going to have some years that are bad for worms because it's really hot and dry, and that dryness dries out the larvae. You're going to have other years where it's nice and wet, you've got a lot of rain, the worms love moisture, and it's nice and warm, and you get intense worm transmission. So it varies a bit from year to year. Sometimes I'm asked what impact climate change might have on these parasites. And it's probably a little too early to make very accurate predictions, but what we might expect is reflected in this graph that I have shown on the slide. This graph shows the changes in the growing season in Vermont from 1960 to 2010. On the horizontal axis, you can see the year, and on the vertical axis is climatic conditions. So the green line represents the length of the growing season in Vermont. And in 1960, the growing season was actually about 2 weeks shorter than it is in 2010. The blue line shows the period during which you can expect frost in Vermont, and that overall length of time has decreased from 1960 to 2010. So this information suggests that we're seeing a definite change in the growing season, indicating that conditions are warmer. We know that Haemonchus likes warmer weather, especially warmer weather with moisture. So we probably can predict from this kind of information that the transmission season for Haemonchus in Vermont is also going to increase. So when it comes to getting rid of worms, we have to accept that this whole group of worms, including barber pole worm, are really part of the world of sheep and goats. If we could go back to that first appearance of what we would recognize as a sheep or a goat, and then follow them through their evolution, we would see that the worms are in them right from the start. These worms have evolved along with their sheep and goat hosts. And where we really see parasites as a primary disease problem in ruminant animals is where our management practices have altered that normal relationship between the host and the parasite. So management is a critical part of parasite problems. These are really management diseases, and they tend to occur because we've taken free-ranging animals. The photo on the left is of mouflon sheep, a wild sheep breed. We've taken those kind of wild animals that roam over large spaces, and we've put them in more restricted spaces, and we've said, okay, you have to eat right where you defecate. You have to eat right where we're going to have the most parasite larvae available. And this, over and over again, is what leads us to the development of serious parasitic disease. So our management practices are going to try and help us do what we can to avoid these situations of heavy exposure to parasites. But let me say, too, kind of what I said before, if you think you want to eradicate worms, this is basically how your small ruminants are going to have to live. They're going to have to share your household with you, because if they're eating grass, they're going to have some worms. This sheep clearly leads quite an exceptional life. Why are worms such a problem? If you've been raising sheep or goats for the last 30 years, you'll know that 30 years ago we didn't have this problem we have today. And the problem has arisen because we're dealing now with dewormer resistance in the parasites that we didn't have to struggle with before. So I want to review with you a little bit of information on dewormers and on how dewormer resistance develops. Now, you're going to say, well, I walk into the feed store to get some dewormer, and there's so much to choose from. These are all commercial products that you can find to one degree or another at the feed store. And we have been so lucky over the last 50 years. We've had these highly effective drugs that are safe to administer. They don't require a veterinarian's prescription, and they're really, relatively speaking, very cheap. We've been so fortunate, and you would think, how can dewormer resistance be a problem when I have this huge number of parasite deworming drugs to choose from? But the problem is this. Those top two drugs they're two preparations of the same drug. So they're the same. One is not different from the other. You can see that second equal sign. Again, those are two commercial products that are different, but they have the same drug in them. And that's also equal to that third product that's sitting there as well. It's all the same drug. Different commercial preparations, all the same drug. Going down to the next row, there's two other products. They're the same drug. They're not different. Even though they're different, they have different trade names. The same down below on the bottom line, we have two other products that are the same and another product that's the same. So while it may seem like there's a huge number of drugs to choose from, in fact, there really isn't. And all of the dewormers that we have available to us right now fall into three drug groups. We have the group we call the benzimidazoles. And this drug group contains a drug you're probably very familiar with, Safeguard. There's also a commercial preparation called Panacur. So fenbendazole is one member of this group. Another member of this group that will be familiar to you as a sheep or goat producer is valbazen, or albendazole. And then there are a couple of others as well that are not used very much. The second major drug group is the macrolides, or macrocyclic lactones. And these will be very familiar to you as well. The most widely used one is ivermectin. Another one that's used more in cattle is doramectin. Aprinamectin is also a cattle drug. And then the final member of this group is moxidectin, which will be familiar to you as the trade product Cydectin. And then the third drug group that we have represented is what I call the nicotinics. And it has in this group, we have in this group levamisole, which is sold as Prohibit. There's a new preparation of levamisole that just came on the market called Levamed. And then there's Pyrantel, which if you have horses, you'll know that drug as Strongid. And then Morantel, which is sold in a variety of different preparations. So 3 drug groups, lots of drugs, 3 drug groups. And why does that matter? It matters because if a worm is resistant to one member of the drug group, you have to assume it's resistant to all members of that group. So we don't have all those products that I showed you. We have basically 3 products to choose from. Once worms become resistant to all 3 of those groups, then we're left without much. Now, ivermectin and moxidectin, or Ivomec and Cydectin, are a little bit of a special situation. Within the macrolide group, there are 2 subgroups, and they're a little bit different from one another. So ivermectin is a little bit different from Cydectin. And when Cydectin first came on the market, it was in fact effective against worms that were resistant to ivermectin. But because they're in the same major group, Cydectin does not work for a long time after you lose ivermectin unless you're being very careful. And I have the results here of a study that was done now in 2001, which is getting to be a long time ago, down in Georgia, where a survey was done of resistance to these drug groups in goat farms in Georgia. And the results of that study found that more than 90% of the farms had barber pole worm that was resistant to both ivermectin and albendazole, or resistant to both Ivomec and valbazen. That was right at the time that Cydectin was introduced. And they really they found that Cydectin would still work. But going back a couple years later, already the Cydectin was being lost because the worms were predisposed to be resistant to Cydectin because they were already resistant to ivermectin. Now you may say, well, that's Georgia. Georgia has a lot longer worm season than we have maybe here in New England. But in fact, Dr. Peterson and I have done survey work of sheep and goat flocks and herds in New England, and we found that half of those groups of animals that we could test had evidence of drug resistance there too. So this is not a localized problem, this is a widespread problem throughout the US. So what is resistance? Resistance is inherited change in a parasite population that's produced by drug use, so that a drug that used to work no longer works. So critical to understanding resistance is recognizing that this is inherited change in worms. So one generation of resistant worms can pass that on down to another generation of resistant worms. We make some major assumptions in our understanding of resistance. One is that at any given moment, there are always some worms out there on your property that have the genetic ability to resist a drug, even a drug that hasn't been invented yet. And the ability that genetic change in those worms arises as a result of random mutation. So there's always random mutation going on, and there's always the presence of a few worms that can resist the activity of a drug. But if that drug is not in use, those worms have no selective advantage. They're probably not going to persist. Their genetic influence isn't going to really persist in the population. But as soon as you start using that drug, those few worms out there that can resist it have a selective advantage. And with continued use of that drug, those worms are going to reproduce with one another, and the population of worms is going to gradually build up that can resist the effects of the drug. The problem we have with dewormer resistance is that it's very difficult to detect in the early stages when you could really try and do something about it. So the reason for that is that each worm, these are complex multicellular organisms, and each worm inherits, as for every other trait, the ability to be resistant to a drug, inherits material from the mother and from the father, in the same way we inherit genes for different traits. So I've shown you here 3 types of worms. We have the happy, fully susceptible worm that we can kill with the dewormer easily. We have a rather alarmed-looking worm that's inherited one susceptible trait gene and one resistant trait gene from the 2 parents. And then finally, we have the fully resistant worm that's inherited the ability to be resistant from both parents. If we look at a situation before a drug has become available, right? The drug's never been used before, never even been invented. What we're going to see in a group of animals is that most of the worms in the animals, the worms that are out on the pasture, they're susceptible to the drug. We can use the drug, we can get rid of the worms. There might be a few isolated individuals out there that have this through mutation, just through mutation, have the ability to have some resistance to the drug, but by and large, they're not going to have any impact on the population. Now, once we start using a drug, what happens is that the proportion of the worms with those resistant genes starts to increase in the population. So you can see here, we've treated the animals, and we've gotten rid of all the worms that were in the animals. We haven't changed the number of worms that have that ability to be resistant, but we've increased their proportion in the population. So if there are more of them in proportion in the population, we're increasing the chances that they might mate with each other. So over time, we're going to increase the number of worms that have the resistance alleles, that have the ability to be resistant. So what it looks like when you are dealing with a group of animals where the worms are becoming resistant, what it looks like to you is over a period of years, and that can vary, it depends on the situation, so I've made up a fictional example here, but over time, the efficacy of the drug starts to fall off. So in this example, in year 1, the drug was 98% effective. By year 5, it was only 70% effective because it was used a lot and in lots of situations. You may not be able to perceive that there's any difference because if you go in and you get rid of 70% of the worms, what you're seeing in the animals, the fact that most of them look fine, they're growing, what you're seeing is that this drug is still fully effective. And you may not be able to perceive a decrease in efficacy of the drug until a large proportion of the worm population is resistant. So in my example, by year 7, the drug was only 30% effective. Year 8, it was 15% effective, and now you have animals dying of parasitism because you give a deworming treatment, nothing happens, basically. What we see is that by the time resistance to a drug is typically detected, most of the worms are resistant. And then, if you try and just withhold the drug and say, well, I'm not going to use this for a few years and then I'll be able to use it again, that does not generally work. So by and large, once you lose a drug group, once it stops being good for your use, you have to assume it's not going to come back again in a reasonable length of time, you've lost it. So you got three drug groups to select from. Once you lose those three, right now, that's it. You have no commercial dewormer to turn to. So if you just think about the sorts of management practices that we routinely use, how we might be speeding up the development of resistance, if you were in the room with me right now, I would ask you to tell me what management practices you think we use that would speed up the rate of development of resistance to drugs. And I think immediately what would first come to mind is frequent treatments. And certainly that has been identified as the most important component of parasite control programs that has selected rapidly for resistance, frequent treatments. Secondly, treating all the animals at once has been important in selecting for resistance. And when I think back to 25, 30 years ago and the recommendations that I would make in my area, which were to treat all the animals every month during the grazing season, that was a huge amount of drug use and selected rapidly for dewormer resistance. Another factor that selects for resistance is underdosing animals. So we want to be sure not to underdose them. Treating and moving animals to new pastures also selects for resistance. Even though we used to make that as a routine recommendation, if you think about it, if you have a group of animals and you deworm them all, and then you move them to a pasture with no worms on it, the worms that are going with the animals are the resistant ones. So you're not taking very many worms necessarily with you, but all the ones, or mostly all the ones you're taking, will be resistant. We've also found that treating animals at times of the year when there aren't very many worms on the pasture also selects quite rapidly for resistance because there aren't very many worms out there that are susceptible to replace the susceptible ones that you removed with your deworming treatment. And all these practices tend to decrease the refugia on your farm. The refugia is the part of a parasite population that doesn't get exposed when you give a drug. So here I have a group of goats on pasture, and they have red squiggly lines, right? The red squiggly lines represent worms. So we see worms in the animals, then we see worms on the pasture in the form of the larvae that they can ingest. If we deworm all the goats, we get rid of all the worms in the animals, and now our refugia is just the worms that are on the pasture. If I deworm only one of the goats, now the refugia is the worms on the pastures plus the worms in the animals that didn't get dewormed. So the refugia is those parasites that don't get exposed to a drug when you give it. Now, why do we care about the refugia? What we really want is a situation that when the worms, all your worms are looking for mates. Their goal is to find a mate in the GI tract, mate, reproduce, get those eggs out there. We want a situation that when those worms are going to the big worm dance and they're looking for their mate, we want there to be enough worms that you can still kill with a drug to get in the way of any two resistant worms mating, right? So we got two resistant worms in this photograph. We want them to not see each other because we don't want them producing lots more resistant babies. We want them to find, before they can mate with another resistant worm, we want them to mate with a susceptible worm. And that's going to dilute out the impact of the genes that they have. It's going to slow down the accumulation of resistant worms. We can't get rid of these resistant worms readily but we can slow down the rate of progression of resistance. That's what we're trying to do. Parasite losses are largely a management disease. We have ways of controlling parasites, but none of these mechanisms for controlling parasites will work for everybody, usually. Generally, what we have to do is say to a producer, here's a smorgasbord of parasite control options. You are going to have to decide which ones work best in your situation. And then you take all of these small pieces and you put them together and create an integrated parasite control program. So what I'm going to be doing is presenting in a broad overview way the kinds of techniques that you can use. And for a number of these, I'm not going to be able to give you a lot of specifics, but I'm going to give you the general categories of techniques you can use, and then you'll be able to go and find more specific information. And it's different for everybody. I can't emphasize that enough, because the goat operation in the photograph on the right is so completely different from the one on the left in terms of the forage being presented, in terms of the movement of animals. So no two situations are exactly the same. And that's why we can't give you the kind of specific recommendations that I know you would like to be able to get. So now I'd like to talk about some specific elements that you can incorporate into an integrated parasite control program. So as I said, we're looking for components of a program that we can use in a sustainable system where we're not dependent on use of drugs to which the worms are going to become resistant. Our goal is to not eradicate the worms, because we have to just accept that we're not going to be able to do that. Our goal is to keep the worms at a level where they really are not going to have any detrimental health effects. There's nothing wrong with the animals having a few of these parasites. We just want to make it a level that can't harm them. Now, in my mind, there's three ways to do this, three big categories of things we can do. The first of them is to reduce exposure to parasites on the pasture. So just keep the number of worms that animals are exposed to down to a lower level. The second item is to actually use the normal immune response of the host as part of our parasite control. And then the third is using dewormers. And I intentionally put dewormers as the third element, because what you should be doing is using as many of the other things as you can, and then only use the dewormers as kind of a backup, as your last resort for parasite control, because we know that dewormers have a limited life. They can't sustain us in parasite control in the way that we relied on them 20 years ago. It just doesn't last. So let's talk about things you can do to reduce the exposure of animals to parasites in the environment. The nuclear option, of course, is to take animals off pasture, because I said, as you remember, that really these worms don't do very well in housing or on dry lot. So in the South, there are instances of sheep or goat owners who just gave up the battle. They could not effectively control worms. They moved animals to a dry lot and then began feeding them grain and hay. So that is something that you can do if nothing else works. It's a dramatic option. Remember that small amounts of grass can be enough. So you may have animals largely restricted to an area of dirt around a barn, but with a small area of access to grass, that small area can be extensively contaminated with larvae and lead to problems in some of your animals. You can try reducing stocking density. So as animals are spread out over a larger area, the concentration of worms will go down. But it's important to remember that you can still have what we call a barnyard effect, where although animals may overall have access to a large area, they really prefer to stay in a limited number of areas, graze those areas much more intensively. Certainly, we see that with our own sheep at home, where they have a big field, but most of the time they spend grazing certain small areas within that field, so the exposure to parasites can be quite heavy in those areas. It's not just acreage that's important, it's where they're grazing and where they're spending their time. Another method for reducing the number of parasite larvae on a pasture is to use diversification, so that mixed or alternate grazing with different animal species is helpful. In general, this group of parasites that I'm talking about today is pretty specific in terms of the host animals they want to live in. So the parasites that live in sheep and goats, and also llamas and alpacas, generally do not live in cattle, and certainly do not live well in horses. The same is true of those horse parasites. They will not live in ruminants. Cattle parasites don't live well in small ruminants or horses, and so on. So mixed species grazing, or where animal species are grazed together, or by following one host animal by another through a pasture, usually is quite effective in reducing parasite numbers, and we usually say that one type of animal acts as a vacuum cleaner for the parasites of other types of animals. I've been asked about the value of poultry in reducing parasite larvae on pasture. I think very likely what happens as poultry wander through pasture, they pick apart manure in an effort to find seeds, and in picking apart the manure, they expose parasite larvae to direct sunlight and desiccation, and larvae probably die more rapidly, although that's a slightly different effect than that of a horse, for example, eating Haemonchus contortus larvae and killing it. What's another element you could use? If you have pasture, if you have the luxury of having several fields, after you use a pasture for grazing, you can move animals to a different pasture and then allow the first one to regrow and harvest that regrowth as hay. The process of making hay exposes the parasites again to desiccation, and many, many, many of them die. Many more of them will die than if you just let the pasture sit unused. So making hay from pasture regrowth is a very effective way of killing parasite larvae. And here we have a determined haymaker who's doing the process by hand on YouTube, on a YouTube instructional video. But any way that you can make hay, cut the grass, let it dry, bundle it up and remove it, and then you're getting another cycle of regrowth. Many parasite larvae will die. What about pasture rest and rotation? This is a very common question. I'm going to move animals off a pasture. How long does it need to sit? Well, how long, the length of time that it needs to sit is variable. But there's certainly benefits to letting pasture sit unused compared to just keeping animals on it all the time. You do get some death of parasite larvae over time on the pasture. Also, if you allow pasture to regrowth, you're going to have animals coming back in when the forage is longer. And we do know that most of these parasite larvae they can migrate a distance up the pasture, but they can't usually get much higher than about 4 to 6 inches. So when you're giving animals longer grass to graze, you're cutting down on the ability or you're cutting down on their exposure to larvae because the larvae can't migrate up really high. Now, some of them are real mountain climbers, but we're talking about the majority of the population of worms. So if you are going to use pasture rotation as part of your parasite control program, it's really critical to get the length of the pasture rest right. And it turns out that the length of time that's best for allowing larvae to die off on a pasture is not necessarily the same as the length of time required for the best pasture utilization in allowing regrowth. If you imagine a situation where you remove animals from the pasture, you allow pasture to regrow, and after about a month it's ready to be grazed again, and you bring the animals back, what you're going to find is that in fact pasture larval numbers are really not diminished at all. And we know that probably in temperate areas it's going to take a minimum of about 2 months to make a substantial difference in the numbers of larvae. I mean, larvae are dying gradually all the time, but to really see a decline in the numbers of larvae to make a difference in your parasite control, you probably need to let the pasture sit for at least 60 days. The hotter it is, the shorter the period of time you need to let the pasture sit. There have been studies done in the tropics where a rest period of a month is sufficient to really eliminate most of the larvae on the pasture. For us, up here in the temperate area, it's much longer, and the cooler it is, the longer it takes for the larvae to die. Now, you can use pasture rotation in several ways, and as an organic producer, you can use pasture rotation as your sole means of parasite control. The photograph shows a picture of the organic flock at West Virginia University, and they manage parasites without dewormers by putting sheep on a paddock and then moving them off after 3 days. And that 3-day period is determined by the minimum length of time that it takes for eggs to become infective larvae. So they want to make that move before any of the eggs deposited by parasites in the sheep can become infective larvae. A 3-day move allows them to manage that. And then they wait 2 months before they bring animals back to any given pasture. Now, you can also combine other methods in using pasture rotation. You can graze animals in sequence, so you could have sheep on a pasture and then moved and followed by cattle, and the cattle would help remove parasite larvae that originated from the sheep eggs. You can also use different grazing strategies like mob grazing to quickly bring down forage levels and move animals on before any reinfection could occur. If you're a goat owner, if at all possible, allow your animals to browse. Goats are by nature browsers rather than grazers, and there are in fact some advantages to browsing rather than grazing in terms of parasite control. The first advantage is that browsing will keep their heads up. And you remember I said that most parasite larvae don't migrate very high up off the ground. So goats feeding on bushes are generally going to be up above the level of the parasite larvae. Secondly, we know that there are quite a few plants of the browse types of plants that contain compounds that may actually have some anti-parasitic activity. So goats that are allowed to browse can also consume some of those plant compounds. Sheep will do some browsing as well if given the opportunity, but it's goats in particular that really flourish with some browse plants in their diet. Whatever other methods you use, the pasture with the fewest larvae on it should be used for the most vulnerable animals, always. What are the most vulnerable animals? It's going to be your lactating does and ewes, especially early lactation. It's going to be growing lambs and kids. And it's going to be animals that might be under stress for some other reason, nutritional stress, the presence of another disease process. But in the absence of other diseases or other management problems, lactating animals, growing animals, they always need the pasture with the lowest number of parasites on it. That's where they're going to do the best. Now, I have been talking about ways to reduce exposure to parasite larvae on the pasture. But I want to begin speaking now to what I see as the second element that you can use to design integrated parasite control programs, and that's the immunity of the host animal. Sheep and goats develop immunity to this group of worms. Because we have so many problems with these worms, I think producers often feel that there is no immunity, but there is definitely immunity that is developed to these worms. But the immunity that is normal controls infection and doesn't eliminate it. We're accustomed to thinking of immune responses like those we get from vaccines to preventing infection. Normal immune response to worms controls the level of the infection but doesn't eliminate it, and that means that even immune animals will have parasite eggs in their manure. It's also the case that the immunity that sheep develop seems to be better than the immunity that's developed by most goats. And goat owners will know that some of these recommendations that we make for sheep and that are highly effective in sheep are not necessarily always as effective in goats, because goats don't tend to have quite the same strength of immunity that sheep do. Another thing about the immunity that develops in sheep and goats is that we feel that it's really not going to be there and not going to be reliable in any way until animals reach maturity, sexual maturity. And even beyond that, those animals in their first lactation cycle are still at greater risk of worm problems than those fully adult animals that have had multiple pregnancies. So how can you use immunity then to improve your parasite control program? And there are several ways to do it. One would be to change the reproductive cycle of your animals so that your lambs or kids are older when they hit the peak parasite transmission season. One example of this type of management practice would be fall lambing sheep as opposed to spring lambing sheep. Those sheep that might lamb in the fall, by the time those lambs hit peak parasite season, they're sexually mature or very close to being sexually mature. We also know that the most immune animals tend to be those dry, non-pregnant ewes and does. And even in early pregnancy, they're very immune to parasites. They're so immune that they can even help clean up the pasture. And in the same way that I talked about using a different animal species to come in and graze up larvae, be a vacuum cleaner for larvae, we can do that to a lesser extent, but still moderately effectively with adult immune animals. And if I can give you an example that we encountered here at the University of Rhode Island, there was a group of lambs and ewes that were grazing a pasture. At weaning, the lambs were left in the original pasture. The ewes were moved to another pasture. Not long after that weaning period, the lambs began to show signs of parasitic disease. They became very anemic. and problems with Haemonchus were developing pretty rapidly. So what we did was we just flipped those two animal groups. We brought the ewes back to the lamb pasture, moved the lambs to the ewe pasture, and the ewes were able to graze that highly infected lamb pasture without any negative consequences at all, because their immune response controlled the infection that they acquired, and they managed to kill many of the larvae that were on the pasture. So in thinking about immunity then of host animals, it's important to think about which animals are going to have the most worm problems when they're exposed to heavy infection. We've said that animals develop immune response, but it's pretty easy to figure out which sheep and goats don't have good immunity and are going to be the most susceptible. And that's going to be, first and foremost, young animals. So lambs and kids, everyone recognizes, are most vulnerable. Also, lactating animals. Lactation is a huge metabolic drain on animals. When they're busy producing a lot of milk, they can't quite maintain as good an immune response. So you'll see lactating animals, especially in early lactation, being more susceptible. And then also those animals that are under any kind of stress, that are in any sort of poor health, perhaps because they have other disease issues, or those animals that are on a poor nutritional plane. These animals are all going to be more susceptible to parasite infection. But there's also another important component of immunity, and that component of immunity is inherited. It's the genetic ability to be resistant to parasites. So each animal is inheriting genes that determine just how effective their immune response is. And that ability, individual ability to mount an immune response, really lies underneath every other more temporary factor that we might consider. All animals develop immunity. Some just do it better than others. And what determines how good you are at becoming immune to a large degree is determined genetically. So all other things being equal, we say about 30% of the animals have about 80% of the worms. Okay? So you take your animals, you look at your animals out in the field, and if you counted up every single worm in all of the animals, you would see that about a third of the animals are actually carrying about 80% of the worms. So it's not evenly distributed amongst your animals. And I have an example here of this from my sheep. So I went out one day and picked up a fecal sample from each sheep. And then I determined the number of eggs in each gram of feces, and I plotted those results out in this graph. So each dot represents an individual sheep, and to make it easy to appreciate, I just did them from low numbers to high numbers there and ranked them. So you can see it makes a curve, but each dot is an individual sheep. And you'll see that most of the animals have fairly low fecal egg counts. The egg counts are that vertical axis. So most of the animals clump in the area of fairly low fecal egg counts. But on the right-hand end of the graph, you see there are some individuals that have very high fecal egg counts. So that's my 30%. That's my 30% of the animals that have 80% of the worms. So how can you use the immunity of the host? Well, in the first place, you can use the immunity of the host to try and keep animals that have better resistance to the parasites. Now, there's two ways to do that. One way is to start at the end where you identify the most susceptible animals and you cull them from the herd. So if I go back to the slide of my sheep, on the right-hand end of the graph, there's about a half a dozen sheep there that really represent the most susceptible ones. I should strongly consider culling those animals if I want to improve parasite resistance in my flock overall. What we have found is that using the FAMACHA system where you're checking for anemia, that's an effective way to identify animals for culling. I'll be mentioning more about that in a moment. I do get asked by people if in a group of animals, if they see perhaps does or ewes that need to be dewormed during lactation, if that means you should get rid of them. There's a complex series of priorities here. If those are animals that had triplets, and having triplets is important to you, you have to recognize that the stress of lactation, the need to put all your resources into producing milk for triplets, is probably going to make you more vulnerable to worms. If your priority is easy lambing and kidding, and you don't want to worry about problems with triplets because of worms, maybe you should get rid of those animals. If your priority is having high litter numbers and you're willing to nurse those animals through increased parasite problems, then that influences your decision as well. So I don't ever want to suggest to anybody that your priorities are all going to be the same. But I strongly urge you to consider the genetic contribution to resistance and to do what you can to make your animals more resistant to parasites. So we mentioned culling. On the other side would be positive selection, where you make an effort to select animals with improved parasite resistance and include them in your breeding program. Now that's easier or harder depending on the situation you're in. If you're buying animals, it may be difficult to get parasite information on those animals. But within your own flock or herd, certainly keep records so you can evaluate parasite resistance and use parasite resistance in making deworming decisions. We have on the University of Rhode Island Small Ruminant webpage a video on using fecal egg counts in parasite management that talks about selection decisions using fecal egg counts from animals. You could use breeds with higher levels of resistance to parasites. There's a fair amount of information now that there are some sheep breeds out there, St. Croix and other Caribbean breeds like the Barbados Blackbelly. You can see those West Indian hair sheep in the two pictures at the top there. But Katahdins are also have improved parasite resistance. Katahdins are a breed developed in the US, another hair sheep breed, but have higher levels of parasite resistance, have become very popular in the southeastern US. And then there's also some Gulf Coast, Florida natives, Louisiana natives that are wool sheep, but just through many, many years of having to survive in a worm-ridden environment, they have become more parasite resistant. So you can select for sheep breeds that are a little more resistant, but you have to keep selecting for resistance if you're going to have those breeds. We know less about breed variation and resistance in goats. There's been some suggestions that Kiko goats, pygmy goats may be more breed resistant, but there's not a lot of scientific literature published that confirms that. However, any group of animals can be made more parasite resistant with selective breeding. The other important use of immunity in parasite control and integrated parasite control is targeted selective deworming programs. A targeted deworming program has you deworm those animals that really need it. Because most animals develop immunity, and that immunity is going to really sustain them in their battle against worms, there are an awful lot of animals that don't need to be dewormed. And in the past, we said you deworm everybody, do it all the time, Effectively, we were saying treat all the animals like the most vulnerable animal, and then you won't have any worm problems. And that was true. That was certainly true, but we used up the drugs, so we can't do that anymore. What we want to do now is deworm those animals that need to be dewormed and not deworm the ones that don't need to be dewormed. And that way, we really slow down the development of resistance. So you're using less dewormer. It's more inexpensive to target deworming, to use targeted deworming, but it increases the refugia. And that is the big thing. It slows down the development of resistance, and those drugs that we have will continue to have for a longer period of time. So targeted selective deworming works for everybody in the herd, not just for that top third of the animals that you're going to deworm. And the reason that's true is demonstrated in these two graphs. These graphs represent two different goat farms. If you look on the vertical axis, you can see that at the goat farm in the top graph, the fecal egg counts go all the way up to almost 20,000 eggs per gram, which is very, very high. The bottom graph shows a farm where the peak fecal egg count is only about 4,000 eggs per gram, which is much more typical of what we would see on a lot of goat farms. Along the horizontal axis are portrayed the fecal egg counts of each individual goat in both of those herds. And you can see that the shape of the curve that occurs here is very similar to the one that I drew for my sheep when I showed you the graph of my sheep's fecal egg counts. So that only about 30% of the animals are carrying about 80% of the worms. And you can see that black line demonstrating where that 33% occurs. If you deworm the top 30%, you get rid of 80% of the eggs, and that means that everybody in the herd is reduced to a much lower level of pasture contamination because so few eggs are left. In this case, only 20% of the eggs are still being produced by the remaining animals. So targeted selective deworming makes the pasture safe for everybody, or makes the pasture safer for everybody. For selective deworming, for making decisions about who to deworm and who not to deworm, the very best program we feel in the eastern US is to use the FAMACHA selective deworming system, where you are assessing the level of anemia. It's a direct assessment of the level of anemia produced by barber pole worm, and you use that to decide who to deworm. It only works where barber pole worm is the principal parasite problem that you have, but that's most of the eastern and midwestern US. On the University of Rhode Island Small Ruminant website, we have another video that we've produced on using the FAMACHA deworming system and giving you a very clear demonstration of how to do the scoring, how to get, how to incorporate that system into your parasite control program. My personal feeling is that every sheep and goat owner in most of the US should have a FAMACHA card, and they should be using it in their animals. It's a great system. So we feel strongly that the FAMACHA system and program, when it's done correctly, is a great targeted selective deworming program, works well in the eastern Midwestern US. I think everybody who owns sheep and goats needs to have a FAMACHA card, needs to be looking at their animals with it. You can also use fecal egg counts to make deworming decisions. It is certainly more labor intensive to do that. And fecal egg counts are not always directly linked to the effects of the parasites in the same way that the anemia score is. So I don't feel it's quite as effective a selection system, in addition to being much more cumbersome. If you would like to use it, we do have a video on the URI small ruminant webpage on using fecal egg counts in small ruminant parasite control, but you'll see on that video that we do not stress it as being a sole means of making decisions about deworming. Now, if you have both the FAMHA scoring system in combination with fecal egg counts, that's more information. The more information you have, the more refined and sophisticated your decisions can be. Now, we'd like to see everybody using individual targeted deworming programs like the FAMHA program, because it will have the greatest impact on the rate of development of resistance. It will slow it down the most because you're just treating individual animals. You're not treating big groups, you're not treating everybody. However, even group-targeted deworming is better than treating everybody. So in some circumstances, treating lambs, all lambs are kids, might be a decision that's made. That's better than treating everybody, treating adults too that don't need it. So I would encourage you to do an individualized selective deworming program. There are circumstances, however, where animal numbers may be so great that it's not practical to do that. But anything you can do that does not treat all the animals at a time, anything you can do to reduce the number of animals being dewormed is beneficial in slowing down the development of resistance. One element that is really critical to animals developing a good immune response is adequate nutrition. Nutrition is important in allowing the immune system to create the antibodies and the cells that are used against parasites and other pathogens. Studies that have been done in recent years indicate that increasing protein levels over recommended levels may be particularly helpful in growing animals and lactating animals in ensuring that there is an effective immune response present, or at the very least helping animals repair the damage done by the parasite by helping them replace red blood cells that have been consumed by barber pole worm. Now, there's no hard and fast rule about the levels of protein that would be helpful in these circumstances. There have been a variety of studies done. In some studies, these responses have been quite dramatic. In others, they haven't been. So it's very difficult to give you an actual guideline about the percentage of protein that should be used. Sometimes you'll see 18% mentioned, but that's not consistent. The results you're going to get isn't consistent, but it's important to remember that good nutrition, not only energy levels, but certainly protein, also vitamins and minerals, are critical to the development of the immune response, critical to helping animals withstand the harmful effects of the parasite. The third element that you can use in designing integrated parasite control programs is dewormers. Now, I've intentionally left dewormers to the end because I want you to first use reducing the number of parasite larvae on the pasture and the immunity of the host in developing integrated parasite control programs. Dewormers come in at the end to help you with those situations where you need some additional activity in a targeted selective program, in use in particularly vulnerable animals. That's where we use dewormers, not as the primary means of parasite control. These dewormers, although there are a variety of them out there and available for use by producers, these dewormers are not all approved by the Food and Drug Administration for use in sheep and or goats. And it's very important to involve your veterinarian in the selection of dewormer drugs. If you are using a dewormer in a manner for which it has not been approved, then you really need the input of a veterinarian. Now, in dewormer use, there are several important considerations to using them most effectively and efficiently. The first of these is that you use the correct dose. And what we know now that we didn't know some years ago is that sheep and goats metabolize dewormers differently. It used to be assumed that the appropriate dose for sheep would also be the appropriate dose of a drug for goats, and we know now that with the dewormers that is not the case. And so the research that has been done has shown in general that the effective dose for goats of a dewormer drug is usually twice the sheep dose. Now, there are a few exceptions that I'll mention. One is that for levamisole, which is approved only for sheep, there have been studies that showed it was effective in goats and effective at a dose of 1.5 times the sheep dose. And levamisole has a slightly lower safety margin than the other dewormers, so it would be better not to use more than you actually need to use. I would also like to point out that Safeguard or Panacur, those are two commercial preparations of fenbendazole, that drug is approved for use in goats. However, the dose that appears on the label for goats is not high enough. It is what was determined to be the sheep dose in other experiments. So that dose of dewormer that you see on the label for goats for Safeguard should also be doubled. Now, this whole dose issue is quite confusing because we have differences in sheep and goats. And we do have on the University of Rhode Island small ruminant website some dewormer charts, dosing charts, that were prepared initially by the American Consortium for Small Ruminant Parasite Control. And they lay out very clearly how much of these drugs should be given to animals of different weights. So if you're at all confused or uncertain about appropriate doses to use, I highly suggest that you go and have a look at those charts. I'd also like to point out that withdrawal times for these drugs are very important. And particularly for those drugs that are not approved for animals, you must consult a veterinarian in order to get recommendations on appropriate withdrawal times. And then you should also know for those approved drugs what the labeled withdrawal times are. Another key to using dewormers appropriately is not to underestimate weights. If you are going through a group of lambs to determine which ones need selective deworming treatment, and you identify half a dozen that need to be dewormed, don't take that group of lambs and say, well, the average weight is 60 pounds. Look at that group of lambs and say, well, I think the maximum weight in this group is 80 pounds, and then deworm for 80 pounds. There was a well-known study some years ago conducted in Australia where experienced sheep producers were asked to estimate weights, and they all underestimated, or they pretty consistently underestimated. So we want to make sure that you don't underdose. If you underestimate animal weights, you underdose. Of course, the preferred technique would be that every producer would have a scale and would weigh animals individually and dose based on individual weights. But if you can't do that, base your dose on the heaviest animal in a group. We would also ask that you give dewormers by mouth only. We know that use of injectable products will increase the rate of development of resistance. When you are using products by mouth, it's very important to put them in the back of the mouth. For one reason, they're harder to spit out if they're placed in the back of the mouth, over the back of the tongue. But the other reason to place drugs in the back of the mouth is particularly important in young animals. Young animals will have a suckle reflex. They suckle milk, and when they suck and milk is deposited in the front of the mouth, there's an anatomic structure called the esophageal groove. And when the esophageal groove closes, the milk travels from the mouth directly into the abomasum, and it bypasses the rumen, which is exactly what we want for milk, but it's not what we want for dewormers. For dewormers, we want the drug to be deposited so that it will go into the rumen. When it goes into the rumen first, then it spends a longer time traveling through the gastrointestinal tract, and that allows for higher levels of absorption, greater efficacy of the drug against parasites. So we want to make sure and deposit the dewormers that we give in the back of the mouth. And in the photograph there, you can see several types of nozzle that can be placed on dosing syringes that help deposit the drug right at the back of the mouth. Some people I have talked to have told me that they've used horse pastes to deworm sheep or goats. Firstly, those are not approved preparations for those animals, but I feel that pastes, because they get caught in the mouth, in the front of the mouth more readily, are easier to spit out. They're also harder to dose accurately because they're aimed primarily at deworming horses or cattle. There are no paste formulations that are approved for sheep or goats. You also want to remember that if you are treating animals that are clinically affected by barber pole worm, that it's really important to provide supportive care. If these animals are so anemic that they can barely stand up, you have to get them off the infected pasture. If you don't, they will continue to be infected, and they'll replace any worms that you just got rid of by ingesting new ones. So remove animals from infected pasture. Make sure you give them really great, high quality food so that they have adequate protein, adequate nutrients to replace all those red blood cells that have been lost. And then you also are reducing their risk of reinfection. Now, there are a couple of things that you can attempt to do if you believe that your drug is starting to lose its efficacy, but you want to keep using it before trying to use another drug. There are a few things you can do to return the drug to a higher level of efficacy. These would include increasing the dose, doing things that would maximize drug absorption, and using multiple treatments. But these are all short-term fixes, and they will not last for an extended period. They'll work for a while, but they're not going to last for a long time. And you should also remember that if you do things like increasing the dose or using drugs at different intervals, you are now potentially using the drug in an off-label manner. It's not consistent with the label, and then that means really you should make some of these changes only in consultation with a veterinarian. Also, changing dose and administrations may change the withdrawal times for these drugs. The first temporary measure you can follow to try and improve the efficacy of the drug is to increase the dose. Now, the degree to which the dose should be increased will vary a bit with the drug that you're using, with the age of the animal that you're dealing with. And so again, I suggest that before trying this, that you consult with a veterinarian to determine what's safe and effective in your animals. You can also try maximizing an absorption of the product, and there's been some research done specifically with benzimidazole drugs. Probably this also applies to the macrolides as well, where food was restricted for 12 to 24 hours for animals, and then they were treated. And by restricting feeding before treatment, you slow down rumen movement. As you slow down the movement of the rumen, you keep the drug in the animal longer, you increase absorption. We would say, of course, don't restrict food in late pregnancy. You don't want to put those animals in a perilous state by restricting their food. You don't restrict water, but just hold them off food, perhaps overnight, before you deworm them. You can also try multiple treatments, and in the protocol of food restriction, you can give a second dose after restricting food for a further 12 hours. So you keep them off food for 12 hours, dose the animals, keep them off food for another 12 hours, dose them again. And again, that helps restore the efficacy of drugs that are losing efficacy. So a drug might be 70% effective. You can bump it up again by trying some of these different techniques. I've talked to a number of people who say, well, I'm just going to give a drug every day for 5 days. That will work too for a while, but I want to emphasize these are relatively short-term fixes. If you already have a fairly substantial population of resistant worms, they're just going to be able to kind of amp up their level of resistance, and eventually these other techniques will not be effective either. What is being used more and more, and which I certainly think we are coming to rely on to a greater extent, are combination treatments. A combination treatment is when you give 2 or 3 drugs from different drug groups at the same time. You give them at the normal dose at the same time. Now remember, we're talking about the different drug groups. These 3 different main drug groups all work in different ways, so that when you give representatives from each of those groups at the same time, you're not going to run into toxic effects because they're all working in different ways. Using a drug combination is, I think, particularly important when you're bringing in new animals where you don't know anything about their history in terms of what drugs are effective. So you would bring in a new animal, treat it with multiple drugs from different drug groups, and then part of introduction of any new animal to a group is quarantine. You want to be quarantining animals for a number of different reasons to help with infectious disease. So you would use a combination treatment followed by quarantine. I also would suggest that if you have a severely clinically affected animal and you're uncertain about the efficacy of your drugs, that using a combination treatment in those circumstances might allow you to save a life where otherwise you wouldn't be able to save a life. And then also, I think they are now of use in targeted selective deworming programs where other things, single drugs, just don't work. We know there are many herds and flocks of animals, especially in the southern US, where Haemonchus is resistant to all 3 drug groups. And the only way to get real efficacy of a drug treatment is to use this combination treatment. By giving drugs from different drug groups at the same time, you get an additive and even synergistic effect of the products that you lose if you try to give ivermectin on Monday, Safeguard on Tuesday, and Prohibit on Wednesday. They would be given at the same time. Now, do not use combination treatments where you just go out and deworm everybody. If you do that, what you will do is end up with resistance to everything in no time. So we're going to use the combination treatments strategically and carefully so that, again, we're protecting the drugs as long as we can. Several questions that I've been asked in the past include, should I rotate drugs? If you've been raising sheep or goats for a long time, you'll remember that in the past we would say you should rotate your drugs so that you would use one drug group this year, you'd use another drug group next year. That recommendation is no longer being made because there is so much drug resistance that really you're not accomplishing very much by rotating drugs. We're seeing multiple drug resistance. We're seeing populations of worms where drugs are only partially effective. So that sort of annual rotation of drug groups that we used to recommend, not anymore. Now the recommendation is if you have a drug that works, use it, use that drug group till it fails, and then try and find another one, or if everything has failed, go to the combination treatments. Should I treat animals before moving them to clean pasture? I think we've already talked about this a bit. You remember that I said earlier, if you deworm animals, if you deworm all animals and you move them to a clean pasture, the only thing they're going to take with them is resistant worms. So the recommendation is no. Do not deworm all animals and move them to a clean pasture. So no longer do we say deworm everybody and move them to a new pasture. That is a practice that selects for resistance. We also do not want to deworm all the animals at the same time. I suggest that you check to see if your dewormer is working. If you still are relying on one dewormer, I really think it's worthwhile knowing if there's already a resistant population of worms present. You can do this in two ways. You can do a fecal egg count reduction test, which involves taking fecal samples from a group of animals, deworming them, and then checking them again in about 10 days to 2 weeks, and look for the percentage reduction in the fecal egg counts. An alternative method to determine dewormer resistance is to do the Drench-Wright test, which is a test offered by the University of Georgia. Producer collects a composite sample from several animals, sends it off to the University of Georgia, and they can actually run the test in this little 96-well plate that's shown that has the 3 different colors of columns. Those little wells in the plate have dewormer incorporated into them, and they can add some eggs to each well and then see the concentrations of drug that inhibit the development of the worms and tell you whether each group of dewormers is still effective or whether there are resistant parasites present. It is convenient for producers. It's also quite expensive. In the past few years, we've seen some alternatives to dewormers that have become available. And some of these products are based on research done at universities, published in the scientific literature, related to products that do have some efficacy against this group of parasites. But I do want to point out that the amount of research that's been done on these products is not at the level that we would see in the development of a new chemical dewormer. When a new product like ivermectin or Safeguard comes on the market, it's backed up by millions of dollars and many years of research. Some of these newer products that we're seeing, the amount of research that has been done is much, much, much less. And we do see some effect against parasites. We see producers who are interested in using these techniques, but it's really important to understand that they probably are not going to work for everyone. They're not going to work in every situation. They may not even be safe and lead to good production in every situation because there are so many complex factors involved that we don't yet thoroughly understand. One of these products that has created a great deal of interest is the copper bolus. Copper boluses used in sheep and goats have an effect against Haemonchus that is similar to that of a moderately effective commercial dewormer. Copper boluses contain tiny particles of copper oxide wire particles. And these particles have been shown to have an effect on Haemonchus, not on other parasites in the GI tract, just Haemonchus. It does not appear that other forms of copper, like copper sulfate, will produce this same level of efficacy against Haemonchus. Now, copper is an essential nutrient, but too much copper is a bad thing and can cause copper toxicity. And sheep in particular are more susceptible to having more copper, to developing copper toxicity than goats are. Goats are relatively tolerant to copper toxicity. So copper levels in animals can be influenced by the amount of copper in the soil. They can be influenced by the amount of copper in the diet. And it's very important to have the correct amount of copper and not use copper boluses in a way that would lead to a copper toxicity situation. These copper boluses used to be formulated only for cattle at a very high dose. There are now preparations for sheep and goats specifically, but those copper boluses for sheep and goats are sold to be copper supplements at levels where copper is deficient in an animal's diet. And in an animal with normal copper levels, the amount of copper they would need in order to have an effect against parasites is going to be less than that in one of the standard copper boluses. So at this point, before using copper in sheep or goats as a treatment for barber pole worm, it's very important to check with your veterinarian, to check available resources, do some reading, and find out more about it before you try to use it. And in this, you can see in this photograph a picture of a publication from the National Center for Alternative Technology on the use of copper boluses in small ruminants. And I'm going to give you the website address for that group, and you can get a copy of that publication to read on copper boluses. Another alternative to our commercial dewormers that's come under a lot of investigation lately is the use of plant-based dewormers. We know that many plants produce secondary metabolites that have antiparasitic activity, and these are being investigated extensively right now. The group that's received the most attention are a group of forages that contain condensed tannins. And some of those forages that are grown in the US include bird's foot trefoil, which is found in the northeastern US predominantly, sainfoin, a forage that's grown out west, and then in the south, Sericea lespedeza has received a great deal of attention. The forage that's been examined the most carefully is Sericea lespedeza. It's a forage that has been introduced in a number of parts of the US for things like road stabilization. In some states, it's considered a noxious weed when it springs up independently. But in the southeastern US, it's also grown as a forage species. And there's been quite a bit of work done on that forage plant. I will point out that all the evidence that we have of its effects as an anti-parasitic plant have been done with one cultivar, Auburn Grazer. And those Sericea lespedeza strains or cultivars that grow up on reclaimed mine land in Virginia, for example, no work has been done with determining whether they have any antiparasitic activity, and they may not. But these studies done with Auburn Grazer have shown definite impact against parasites. And again, I'll mention that ATRA does have a publication on using Sericea lespedeza as a tool to manage small ruminant parasites. And for some more detailed information and results of studies that have been done with this plant, I would suggest going to that publication at the ATRA website. Sericea lespedeza is may not be easy to establish. Some producers have found that it's not easy to establish. And particularly in northern states, it does not grow very well. But there has been an effort made to actually create Sericea lespedeza pellets. And those pellets have also been shown to be equally effective against parasites when compared to feeding hay. Sericea lespedeza hay and pellets maintain that antiparasitic activity that the fresh plants have. There is a feed mill in the South that makes these pellets. They are available from several commercial suppliers, and this may be another option for you if you are looking for an alternative to commercial dewormers. These pellets could be fed at specific times when animals are particularly at risk of parasitism and may be a useful tool. There are some commercially available products for parasite control that are unproven. And amongst these would be herbal dewormers. There are several herbal dewormers that are on the market that are not drugs. They're not considered drugs. They're not subject to regulatory oversight by the Food and Drug Administration, so they haven't been tested carefully for efficacy and safety. I think there are plants that do produce compounds that have antiparasitic activity. We know that to be the case. But in these herbal dewormer preparations that are not FDA approved, we don't really know about the levels of plant products that are present. There's no consistency in products from batch to batch, and so there's really no basis for recommending them. Similarly, diatomaceous earth has been recommended as a dewormer product. At this time, we have no real experimental evidence that it's effective. And I and some other parasitologists have done studies where we could not show any benefit to using diatomaceous earth in parasite control, so I don't see any basis really for its recommendation. So you might be wondering if there's anything new on the horizon in terms of new techniques for parasite control. There are a few things. One is a new drug, and there is a drug called Monipantel that's in a completely different drug group. This drug was introduced in New Zealand about 8 years ago, and since then it's been used in Australia and New Zealand, it's being used in South America, it's being used in a number of different countries. It is effective against parasites that are resistant to the other drug groups, but right now we don't have it in the US. They've been telling us for years that it's coming. They're still telling us it's coming. But I think the difficulty right now is that the drug company that made this product was recently purchased by another drug company, and that's put everything on hold. So we're still waiting for Monipantel, hoping it might be available later this year, maybe next year. But when it comes, you're going to have to use it very carefully. We know from experiences in other countries that using this drug, even trying to protect it and use it judiciously, we're already starting to see drug-resistant parasites. So unless this product is used very, very carefully, we're not going to see it last much longer than any of our other drugs has lasted. But we hope it will be available in the near future. A second and very interesting development that may appear in the next year or two is the use of a commercial product of a fungus that actually eats nematodes, eats the larvae of barber pole worm and related parasites. This is an organism that occurs naturally in the environment, and the commercial product that's being prepared would be an additive for feed. It would get mixed into the feed. Animals would eat spores of this fungus. They would pass through the GI tract into the manure, and then in the manure, the fungus begins to grow and develops a net of material that can trap the nematode larvae, and then they feed on the nematodes. And this has been shown to be quite effective in horses, in cattle, and in small ruminants. The initial use of this fungus in the US will be in zoo animals because the drug resistance problem is terrible in zoo animals. But the hope of the company that's making this product is that it can be expanded and become available to small ruminant and other livestock owners as well. The final thing that you may have heard about, because it has been on the internet, is a vaccine for Haemonchus. And this Haemonchus vaccine is available in Australia. It's relatively effective. It's effective, has to be given a number of times. But the bottom line here is that there are no plans to market this vaccine in the United States. It's unlikely that we will ever see this vaccine on the market, at least not in the near term. So right now, although you may read about it and feel that you would like to try it, it's not going to be available here. So I have presented to you suggestions on a number of different techniques that you can use to develop integrated parasite control programs. But there are a lot of other resources out there that you can use. Certainly work with your veterinarian, work with extension agents, any other resources you have available to you. But there are some websites in particular that I'd like to recommend. The first of these listed here is the National Sustainable Agriculture Information Service website. This organization has a wide variety of publications available for all kinds of sustainable agriculture, not just livestock production, but also crop production. It's an extensive website. They have several publications on parasite control in small ruminants. I had mentioned the one on copper oxide particles. These are really excellent publications. They're free. And I highly recommend those publications to you. We've mentioned the University of Rhode Island small ruminant parasite control website, on which you found this video, as well as videos on doing FAMACHA scoring in animals, using fecal egg counts in small ruminant parasite control, and some other resources as well. We hope you'll visit that website and view the other videos we have available. The third source mentioned here is the webpage of the American Consortium of Small Ruminant Parasite Control. This is a group of scientists and educators and extension personnel who have really been committed to improving small ruminant parasite control in the face of extensive dewormer resistance. They have a number of valuable information pieces and links on their website. And then finally, Dr. Susan Sheenian at the University of Maryland has an excellent website on all aspects of small ruminant production, and I'd encourage you to visit that website when you have questions about small ruminant production. In summary, remember that the goal of our integrated parasite control programs is not to eradicate the worms, because we can't eradicate the worms. They're a part of our animals' lives when they're on pasture. Our goal is to keep the worms at a level that will prevent the development of the disease and won't cause production losses. The tools that we've provided to you are those of reducing exposure to parasite larvae on the pasture, giving you ways to incorporate the immune response of the host in integrated control programs, and then finally to judiciously use dewormers in parasite control. Thank you very much for watching this video, and we hope that it has been helpful to you.